Hello, my name is Chisamargu Ibe, and I have the drug methotrexate. So methotrexate is a is an antiperipheral. So basically, what it does is it's a chemotherapy agent and immune system suppressant. It is used to treat cancer, autoimmune diseases. The type of cancer that it is used for is breast cancer, leukemia, lung cancer, lymphoma, and also bone cancer. It is also used for autoimmune diseases such as psoriasis, rheumatoid arthritis, and Crohn's disease. So the task given to us was to find an image in the book and connect it to the mechanism of methotrexate. So methotrexate is associated due to its anti-proliferative characteristic. So the image on the left basically shows you the cancer cell proliferation. So when the drug methotrexate is added, the process of cancer cell proliferation will not occur. So the mechanism for methotrexate is that the methotrexate competitively inhibits DHFR, which is dihydrofolate reductase. It is an enzyme that participates in the tetrahydrofolate synthesis. Once DHFR catalyzes the conversion of dihydrofolate to the active tetrahydrofolate, folic acid is needed for the de novo synthesis of the nucleoside thymine required for DNA synthesis. Also, folate is essential for purine and pyrimidine-based biosynthesis, so synthesis will be inhibited. Methotrexate therefore inhibits the synthesis of DNA, RNA, thymidylate, and proteins. So here you can see the normal cells. It's a slide focused on the difference between normal cells and cancer cells. So on the left, you see images of the receptors. So on the far left, you see a normal receptor. So during normal receptor activation, the binding of a growth factor to its receptor promotes the clustering of two receptor models, therefore causing the tyrosine kinase activity of each receptor to catalyze. So when the growth factor binds to the receptor, that will cause it to be active. However, in the mutant receptor, the receptor is always active, so you don't need a growth factor to bind to it. And the image to the left basically shows the different genes that's associated with normal cells and cancer cells. So you can see that P27 interacts with RB, and P27 is used in cell cycle progression. RB is it provides instructions for making a protein called the tumor suppressor. So basically, the P27 helps with tumor suppression. So does P300 prohibitin and P53. However, with cancer cells, you have SKP2 as an SKP2B, which basically inhibits the genes that aid in tumor suppression. So the side effects and mechanism of methotrexate. So the side effects are dizziness, drowsiness, headache, swollen tender gums, decreased appetite, reddened eyes, and hair loss. So pretty much methotrexate works by slowing or stopping the growth of cancer cells and suppressing the immune system. So as stated previously, let me go back. Oops, sorry. I think this will be. So basically with the side effects, right? I'm sorry. Okay. So the side effects works by, the drug works by stopping the growth of cancer cells and suppressing the immune system. Early treatment of the rheumatoid arthritis or cancer with more aggressive therapy suggestions that helps reduce further joint damage and to prevent joint function. So ideally, the methotrexate with the side effects, basically it will really slow down the growth of your cancer cells, which will really affect the mechanism of the methotrexate. So the Yes. Okay, cool. So the question of the day is there a generic drug of methotrexate, and if so, will it work the same? And here are my references. Thank you.